Hello friends, good evening. My name is Ramji Tripathi and very thanks to all for watching us as a live session on a thermodynamics. This session is organized by the Hnaoi University of Science, Vietnam, and also presented by the Right and Perfect Academy, and organizer as Hnaoi University, Mr. Alex, thanks, and ma'am, Miss ALENE, thanks for recommend to our opportunities to present this lecture on a thermodynamics. Thermodynamics is wide lecture, but here the some important points. What is in your mind are several areas related to our engineering life, our science life, our local life, effect with the thermodynamics and thermodynamics laws. Here we collaborate all the properties related to that. It is most important for us, it is most powerful for us, it is most relevant to our real life is the thermodynamics. Here number of students are learn thermodynamics. After that they will be choose our branch related to thermodynamics as a thermal engineer, as a HVAC, that's mean a heating, ventilation, air conditioning engineer, and also there number of branch where the thermodynamics is correlate with each other. But our university Hnaoi is recommend to the basic ideas to the large applied thermodynamics which have used and why we use to explain in this lecture. Mr. Alex say to me, the thermodynamics is the normally way it is recommended as a basic lecture for diploma holders, ITI holders, and also the BTech, because is basic thermodynamics or thermodynamics as language. Thermodynamics, that means the thermo plus dynamics, it's mean the virtual motion of the thermal and dynamics. Some important points related to this. Suppose when we talk about the heat and work, heat is related to as a correlate, and as a we say that as a replica of work. Why we see that the replica of work? Because when we doing any work, the produce heat, and when we doing any work, then produce heat. When we doing any work as produce heat, and when we application on heat, then doing work. So that is the replica, and it is also the vice versa related to us. Heat and work both are the boundary phenomena. But in our thermodynamics, why we study thermodynamics, what is the fundamental of thermodynamics, what is the fundamental related to thermodynamics in our life, in daily life. We know very well the energy cannot be created nor be destroyed, it's only change from one form to another form. But several engineers want to change one form of energy to another form. Suppose some engineers which have work on solar, they want to solar energy to change electrical energy. And also suppose any electrical energy engineer want to change our electrical energy to form a simple computing system, where the change the life with related to power of mechanics, where heat relevant from one electrons to another electron with the using PN junction or another bus system. So that our thermodynamics is related to each and every person. Thermodynamics is cover. Firstly, what is the thermodynamics? Thermodynamics is the science deals with the heat and work. Also we know that this is energy. Energy is another form where we work to doing something new. because we know very well we don't want to lose the energy. We want to create energy by the some virtual energy present here. If I talk with you and some energy is transferred from one form to another form, so that here the transformation of energy, and so that such as any chemical, here the chemical components are collide to each other, they form to another energy. Then suppose a electrical engineer, they want to a PN junction 1 to 1, suppose 1 to 1 PN junction, one is hole, one is electron, one is hole, one is electron. They want to transfer the energy, so that the energy energy cannot be create nor be destroyed. It's only change from one form to another form. So that we in our mind especially learn, or also the students think all energy are here form in virtual form. What is the meaning of virtual form? Explain in this in this board what is the thermodynamics and virtual energy everywhere. Suppose a man talk with the another man, he dissipate 150 watt energy, and also the one electric bulb such as a CFL or say as the LED bulb, 7 to 5 and 7 to 9 as per use 7 to 9 watt energy dissipate. And another, when we heating substance, then the dissipate heat some 5 to 6 watt. So here the dissipated heat, what will be the dissipated heat is used? The dissipated heat, it's convert from one form to another form. Suppose a beaker in which boil water, it's heated from 100 degrees to 200 degrees centigrade. That means change of phase. When he change of phase, the some energy transfer from one form to another form, because is one energy is as a solid form. When it's heated, change its phase and it's transferred through the evaporation, it goes to the atmosphere. In atmosphere, the sum of energy are effect to another person by the virtual of precipitation, by the virtual of fog, by the virtual of mist. There are the several problems related to the thermodynamics. Thermodynamics is the real branch in which study the energy transfer. If we are sitting here, if you are listening here, if you are watching here, then it's mean energy is present. So energy is everywhere to affect the person by view, by the state, by the country, by the environment, by the atmosphere, by the whole space system. So that first start, what is the thermodynamics? Thermodynamics simply in my language, thermodynamics is the branch deals with the heat and work, and heat and work this also related to the energy. So that thermodynamics is branch deals with heat and work, also deals with energy, That's mean thermo plus dynamics. Thermo, that's mean simply heat and work. That's dynamic, it's in motion. Suppose a steam engine is also the thermodynamics example. Suppose we are a person as a thermodynamic system, because when any engineer learns what is the basic of thermodynamics, then he learns the universe system surrounding. Universe, that's mean whole part of the atmosphere, and system that covers some space which have matter is called the system, and outside the system is called the surrounding, and that's covered with the boundary. That boundary is temporary and permanent. Suppose in any inverse in any universe, that's this word, or we say as a universe. In universe, some system that's contain a space or contains a, that's contain a mass, or matter. This is called the system, where the heat and work are virtually together, or say as the energy transfer from one form to another form. And outside of the system is surrounding. This is surrounding. That's mean any cover parts of the system, and outside of this is the surrounding, and in which where the deals heat and work, in which deals the energy, in which deals the mass transfer, in which deals the transfer of very effective process is called the system, and outside of the system is surrounding. And what is the difference between system and surrounding is boundary. That means cover the system between surrounding is called the boundary. Boundary is two types, is the permanent and temporary. Next, and when we learn about the thermodynamics, give the respect any kind disturbance of the property related to us. In 1870, thermodynamics comes in our branch as a heat, when there is no train, no car, no buses. So that thermodynamics deals with the several properties related to us. So that our process, we want the material. We want first material. The material is the part of our life that deals with another system, and this material goes to trains, car, bus, or vehicles, or say as the any things which converted. So that in our thermodynamic branch there are several properties related to us, such as here we explain that thermodynamics cover the following. This number one, such as a thermal branch is cover geothermal, chemical, solar, electrical, environment, also the effect with the universe contained virtual energy. These are the some point related to us where the deals. Why we say that the virtual energy? It is most important for us. Why we say that the virtual energy? Because virtual energy is formed in different ways. In 10,000 BC, we found out that we can grow our own food. In 10,000 BC, we grown up the food, why we food, and settle the sector, defined the food, with go to the engineer known as the engineering process. In last 10,000 only twice sometimes happened that the transfer humidity, because these are the thermodynamics, geothermal, chemical, solar, electrical, environment. These covered all the different form of heat and work by the virtual in 10,000 year BC. Then after the 1800 year, the confirm the transformation with the deals with energy. The graphical representation by the engineers is such as this. The time here 700, 1800, 1900 and 2000. After that we are come here 2020. To increasing the order of with energy knowing. Increasing the order of energy knowing in year 600, 1700, 1800, 1900, and when 1800 and 1900 the graph is emerged to increasing by the effect of knowing the energy formulas, by the knowing of different cycles, Otto cycle, diesel cycle, dual cycle, and there are the different thermodynamic cycles as the Rankine cycle, steam cycle, and there are the several form of cycles. So in 1800 to 1900 the several change of energy knowing, it's different from to one to another. We want to change the energy one form to another form. We develop different types of invention related to, such as the chemical engineers as mercury defined, and also the different types of potential energy to change the kinetic energy, define the cycling, suppose simple mechanic cycle, and also that these are the era where the energy transfer from basic to requirement as per engineer. After that, here the 2020 want to the know about the invisible energy where we work. Suppose I ask to something, here some words are transferred from me to another, here some transformation of energy by the virtual of frequency, by the virtual of words, by the virtual of in environment present atmosphere, atoms. So that these are atoms. Why the transfer from energy one to another form? It's most important for us, because thermodynamics is work with heat and work. Suppose I work as a speaking to something this, then this is the I am as a system and all the things are surrounding, and my mouth is work as a boundary. But so that when we talk about with you and when we some word say to you, this is the transfer from energy one form to another form. So that this energy, heat is also energy, work is also energy, that heat is also changed from one form to another form. Some mass are also transferred and depends on the system, which type of system. So that our system is three types. Our system is three types where explain all the things. This rules for the system is old, but it's applicable in our universe, in our life from 16 to 2020. It's universe. System are three types: open, closed and isolated. Suppose in any open system, transfer of energy, also the transfer of mass. In a closed system, only the transfer of energy, not mass. In isolated system, neither the transfer of energy and neither the transfer of mass. So that the basic rules of this system, some each transfer. Then if any work, then transfer. If any heat is produced, then transfer. Then transformation is depend on the molecules from one form to another form. So that in our language, thermodynamics is a thermo plus dynamics. They are the some motion with the molecules with the study. So our study of thermodynamics is two types. First is macroscopic and second one is microscopic. First one is macroscopic and second one is microscopic. Macro, that's mean the cover the whole part of the system. Suppose here a beaker, here a beaker, there are the two types of liquid. There are the two types of liquid. One is two types of fluid, liquid, oil and also as water. When we study about the macroscopic, we consider oil and water both. When we study about the microscopic, we individual part of the oil we learn, and we study about the which of the mechanics in here use. We study about learn the atoms or molecules of particular parts of system, as oil, here the some molecules, and water some different molecule. We study about the oil molecules, in which we have the different parts of energy transfer, and water for the parts of energy transfer or say as not transfer. It depends on the system, which type of system, open system, that means energy or mass also transfer, energy and mass transfer. In a closed system only energy transfer, and in an isolated system neither energy nor mass. That means nothing is transferred from one form to another form, is called an isolated system. What is the example related to open, closed and isolated system? In simple way, in an open system in our daily life we use such as AC, compressor, evaporator, condenser. These are the transfer energy also mass is transfer energy also mass is a open system. Closed system, suppose as a fridge is a refrigeration system, is a closed system, only the transfer of energy, not change to mass. And also the closed system as a suppose basic example in which study, suppose this beaker is shut down with any pot, then this is the system, and here the work with heat transfer, then there is no transfer of mass, only some molecules are collide to each other, they form of energy, this energy transfer from one form to another form, they change our phase or whatever. And in a isolated system neither energy transfer nor, as a thermal flask is the best example for this, and this is dependent on what will be studied. Next, basic is when we learn thermodynamics start from the temperature. Thermodynamics start from the temperature. Thermodynamics start with the temperature. Temperature is the part of our life is reference. Suppose we are here present to you as a lecture on a thermodynamics, then is as a reference, so that the temperature is the reference point with two other. Suppose one is system, that's temperature T1, second system is T2. When they both are connect to each other, they define the temperature. So then what is the mean of temperature? Feeling of coldness and hotness is called the temperature. Feeling of coldness and feeling of coldness and hotness is called as a temperature. So that the temperature is the reference point. One is body, that's temperature, this is connect to each other, then this temperature is shown as T1 and this temperature is goes to the explain the T2. What will be the feel as T1 with respect to T2 is increase or decrease, explain in law. Next, how the era change of thermodynamics with different types of energies are come together. In 1700 there are the some cycles are come as a steam engine, Here note down the era of thermodynamics. This is the historical part. Why we study? Because the knowing why, how to come one to one changes. Steam engine, and efficiency, and after that here the some development of, because before it's 1500 to 16, development of thermal cooler, development of thermal cooler, specific heat, Joule's law, specific heat, latent heat. These are the era only for the explain different types of things. After that 1600, after then 1600, the Charles law, Boyle's law, or we say that the ideal gas equation, so that first we knowing the heat, then the era of heat and work. After that the 1840 onwards, the heat is as a work is a heat, law of conservation of energy by the mechanical energy. In 1840 onwards, work on the heat, work as a heat in 1840, and there the law where the mechanical energy comes, electrical energy comes, and several law is related to us. But in our system, work is a mode of energy transfer. Simply, work is a mode of energy transfer such as the mgh, as a potential energy, and here this is work. Suppose one object drop from particular height, and there the some work whose depend on the height, mass, also the which universe here present. That's mean what is the gravitational acceleration, mgh. So that this is simpler work. By the mid 19th century, we found that the heat is a work, or work as a heat. Work in which the transfers different types as a work is a, or work is also say at the ordered motion, or heat is a disordered motion. Why we say that the work is a order motion? Because changing the work or changing the work from heat is by the virtual of effect 1 to 1 to 1 to 1. That's mean what is the mean of 1 to 1 1 to 1? Here explain. If we basic learn what is the work, suppose this is the body where we apply the force, some displacement, after that some displacement, d, that's mean displacement, not a distance, displacement. That's mean work is a force into displacement, force that is the ordered by the acceleration, which is ma. A is the acceleration, that's to change mv by t. And why with this explain here? Because this is the most important our in lecture thermodynamics, we deals with the engine as IC engine, how to is work piston and connecting rod, how to work as a compressor, how to work as a cycling, where the mechanical to change to electrical, electrical change to mechanical. This is most important things, the change from force to work, how to change to force to work here. And basic velocities also change. A is change in velocity, and velocity is change in distance. Sorry. Then here this is the change to d upon t square. Here the put W is equal to F m into d upon t square into d. But there the d is a d is a distance we cover, and this d is a displacement. So that it is most important. What is the distance and displacement? We know very well. So don't explain here. So share the depend on the time. When time increases, work decreases. When time decreases, work increases. So we want here, because we want to some work by the virtual of effect, by the virtual of effect, by the virtual of effect with the given some time. We want to, we have a less time, so that explain all the things in very rapidly. But I have a lots of time, so that here explain all the things by one to one. So that work is depends on the time, and also work is depend on the mass, and also depends on the distance and displacement. So in our thermodynamics law, it's a orders, because it's by the virtual of mgh. Suppose mgh, where the potential energy, and also called the work from change to height. When any object is dropped from the height, is changed to energy. Here the potential energy, there the some work mgh in the form of, when it's drop, is changed to kinetic energy. This is the law, and also known as the, where I cannot explain. But here why this explain here, work is time and mass and displacement, because in our thermodynamics we want to change the law with respect to mass, change with respect to time, and change with respect to distance. Suppose a cycling man want to in a few minutes second we late, and that's mean the it's depend on the what will be the work. It's depend that the work is not rapidly by them, so that he late. And here the work of the system is depend on the time. In a MATLAB engineers and also the psychometric engineer, they depends on the particular time to time to time to time change the particle motion and analysis this. So here the explain work is the order motion. And when we talk about the heat is in the theme simple sir, heat Q is equal to mc delta T. We know very well how the form is Q is directly proportional to m, Q is directly proportional to delta T. That's mean the change in temperature T1 minus T2. Why we called as a disorder? Because the temperature is not uniform and not confirm. Here what is the temperature here? Suppose when we doing any work very rapidly, then the temperature is high, and I asked to do something abusing them, but not here. Is it simply Q is directly proportional to temperature difference? It is because the change in temperature, that's mean the something in a system, that the temperature is virtually different from one to another form. It's environment effect, or the sum as a virtual effect, or the sum of the different kinematic effect. Suppose the one person have different temperature related to the atmosphere, and another body has temperature two different. They depend on the its own. So that here the heat is different, is called as the disorder. Then heat is disordered form, and work is ordered form. Lots of students, they don't know about this form. Then heat is a disorder form and work is the order form. And when we talk about the heat is in a simple way. The transformation of heat, the modes of heats is three types. Modes of heats is three types. First, modes of heat, it three types: conduction, convection, and radiation. In this lecture, we cover all basic parts are used in our thermodynamics. Then in next lecture, if Mr. Alex want to be as a presenter, but Mr. Alex say that explain all basic parts which will be used in daily life, and so that we explain all the things in different way. Thanks to for all watching for us, and also please share and subscribe our Right and Perfect Academy. And also if you want to join us our team, then you subscribe our channel by Right and Perfect Academy, where the lots of lecture related to tech or non-tech. It's depend on you where you want to study. And conduction, convection, and radiation. That's when conduction simply two particles are joined together, the transfer of energy through the touching and through the connecting, so that the one molecule transfer to energy to another molecule by the lattice, by the use of lattice energy. And convection, where the transfer of energy through by the properties of fluids, as Newton's law. Here conduction is Fourier law and convection is Newton's law, and radiation also the different laws as electromagnetic laws as different form as R cos theta square. And convection is the Newton's cooling law. They are the difference, but we not study about the heat transfer. Here he study about the thermodynamics. Then after that there is a several process where the thermodynamics affect our nature, with us process, property, and function. This is most important for all basic engineers, the process, property, and function. What is the mean of process? That means one point to another form changes our properties is process. And function, that's doing anything as like a machine is a function, simple in way. And process, that's a several process we learn and we know about. Isothermal, that means temperature constant, T1 is equal to T2, that means isothermal temperature constant. Second, adiabatic, that means heat transfer is zero, nothing heat transfer but doing any work. This is most important. And this is the effect of law of energy and how to explain this. After that, there is a isobaric. Isobaric, that means P1 is equal to P2, and isochoric, that means V1 is equal to V2, and also hyperbolic and polytropic. There are several types of process. It depends on its property, but we explain only adiabatic, isothermal, isobaric, isochoric. Here some properties we called as a property. What is the meaning of property? Property, that means the several characteristics which have. Suppose pressure is several characteristics. Pressure, volume, temperature. This is the basic characteristics in use in thermodynamics. But when we talk about the all the process, these are the property as explored to in their characteristics. With this the form one point to another form. Function, this relate to two types of one is boundary function and second inexact differential, or say as exact differential. Heat and work also the function is a boundary function, and heat and work as an inexact differential because it's not changed by the virtually is effect to one point to point, it is not changed, so that the inexact differential. Exact differential, that's mean a change some limitation from integration by the 1 to 2, or say as the limit from 1 to 2. That's, but in here the thermodynamics, heat and work does not as a work as a exact differential, is a inexact differential. And the properties, two types of property, intensive property and extensive property. Intensive property, that's mean that does not depend on that mean the depend on the mass, and extensive property does not depend on the mass. There are the several types of property, and in our lecture some application of the thermodynamics in our lecture basically cover the all application. These are the basic rules. These are the basic rules which we study, and that's the doing any things, doing any work. These are the process. Suppose isothermal process, that's mean in mind our the temperature is constant, so that what will be the heat and work. So that when cover all the things here, two of main properties remaining for this length. Suppose as a thermodynamics process is isothermal. In my mind, temperature is constant. What is the effect of temperature is constant? When we talk about the temperature is constant, that means something doing another work, something doing any other thing heats, that is different from the others. Suppose we want to the temperature constant by the virtual effect, and by what is the using then. Suppose as a isolated system where the does not transfer of heat from neither transfer of heat or mass, so that the here the temperature is constant in individual part of this system, into the us the temperature is constant. Then what is the related to work and what is the heat effect, that is most important. When we talk about the pressure is constant, suppose isobaric process, in my mind isobaric process, we want to explain a isobaric process and we want to explain a isobaric system. So those are the engineers which are learn the thermodynamics. They know very well the condenser and evaporator. They are also known as the radiator. In vehicles we use a radiator. In a refrigeration system and air conditioning system we use as a air conditioning system as a condenser and evaporator. Condenser, that's mean the constant temperature device, constant pressure device. Isobaric is a constant pressure device, but in which deals heat and work. This is most important. When we constant the properties, what is the effect of heat, and this is the most important to doing anything which we application are used. Here's some example as a isochoric process, in which process there the volume are constant. Suppose here the some rooms where the volume are constant, that means the when volume are constant, what is the effect of energy changes from one form to another form, what is the change from one form to another form. In our daily life there are several examples related to our this. Suppose a air conditioning system, and suppose a aircraft, airplane, and also the power plant, thermodynamic system, the human body. There are some application of thermodynamics related to the application this. So our new ideas related to engineers, we want to learn the what is the your object related to the process. If you want to the different process are combined together, they form new form of project, that the project is affect the virtual heat. Because we know very well, we don't want to heat, we want to work. We don't want to eat. I have no request to eat, because it is a order form, and this order form is heat is a disorder form. I don't want to eat order form. I want to the I don't want to disorder form. I want to order form. Order form, that's like a work. So we want to something new in our ideas related to work. we want to something new ideas related to work, because of why we want to order work, because we don't have any work, we don't have any work with environment, because nowadays the corona times. So those engineers want to something new related to, they want to study about the how to change the heat to work with the effect of several projects. If you want to our projects as related to our thermodynamics class, so that contact us. Here the 7499246976. And next, now explain the processes. Explain these processes. After that, some two remaining properties explain. Then after the processes, one is enthalpy, second entropy, and another is internal energy. Before explain enthalpy, entropy, first explain internal energy. Energy is virtual form. We know that all the covers energy. Thermodynamics is the branch of energy conservation involving heat and work. Other form, three basic laws, basic concept, property, fluid properties, fundamental process, cyclic application. All the things are cover the energy. But what is the mean of energy? Internal energy. That's mean subtract the remaining energy from the all energy is called the internal energy. That's mean, suppose in our system whole energy is and doing anything, suppose it's changed to chemical energy, work on chemical energy, work on electrical energy, and several, there are lots of energy, E1, E2, E3, suppose E1, E2, E3, then all energy minus E1, E2, E3, E4, and this is called the internal energy. Then the remaining energy is say as the internal energy of the system, because some energy is observed here, any project, any ideas. So this is the energy, internal energy. Suppose how explain this is internal energy in our system. Suppose is it possible if no energy are required? Here the all energy. But when we talk about the energy is present all over. Energy only from transfer form to another form, and energy is present here. And we know that very well. God भगवान हमारे पास चारों ओर present है. That's mean भगवान is like as a energy. God is power of energy. वो क्या है हमारे पास? ऊर्जा का स्रोत हैं, वो ऊर्जा है हमारे पास, और उन्हीं के ही आधार पे हम इस एनर्जी को डिफाइन करते चले जा रहे हैं. दैट्स मीन एनर्जी इन द फॉर्म ऑफ गॉड, एंड नॉट we say that the energy in form of God is energy, and energy is all over India, all over world, all over here the present in each and each point. So that we say that very well, God is present everywhere, so that energy is present everywhere. So God is not created, not destroyed by any others, so that energy cannot be created, not be destroyed by any others. So very well we know about the God, so we know about the energy. And internal energy, that's mean the soul. That's mean the soul. And my soul is says as I have a something energy different from the others. So that the my soul is different from the others, because my soul is thinking to others and thinking to life and doing work, doing things different from the others. So that all energy difference, all energy is present everywhere. Suppose a beaker where the some liquid and is stay about as any table, they have doing any work, it's only stable here. So that we say that it's have a energy, because all the remaining energy are removed from this. and this is stationary, and this liquid is stationary, not doing any work, not doing any collider, the molecules are stable. So that the present of energy by the virtual of mass, by the virtual of effect of molecules are colliding to each other, we know very well the covalent bond and the we know very well the adhesive bond and cohesive bond of the molecules by the adhesive energy and cohesive energy. That energy is called internal energy. So this energy is stable here. All the energy removed from the total energy is called the internal energy. This is the basic law of internal energy. Then what is the enthalpy and entropy? When we call the enthalpy, it is the mean, this is the flow energy plus, this is the flow energy plus internal energy, flow energy plus internal energy. This is the enthalpy. Flow energy, what is the mean of flow energy? Suppose we say that the flow energy, so which type of properties explain the flow energy? Which type of process explain the flow energy? So first, when we talk about the pressure, then pressure is related to force perpendicular area. Then we learn, and in our mind we can say that force perpendicular area, that's mean the something doing work, force then doing work, that's mean the flow. Here the flow. And when talk about the temperature, that's mean change in temperature, and temperature is disorder, so that not flow, so that does not flow. But in volume, there is some volume are different from to another. Suppose here some volume here this and some volume this. By the virtual effect, this is volume is definite, is subtract from this, then the something is flowing from here. Suppose 1 liter, this is the 5 liter flask and 5 liter flask, and this is a 2 liter flask. 5 liter flask, and here the 2 liter flask is mixed with this, then the change, suppose something change at the volume are changing to others. Suppose this 5 liter and this 2 liter are subtract from 5 liter, then something doing change. But in our temperature does not here the remove the temperature from this, here the temperature remove, that's temperature change, does not the temperature remove. We cannot explain as the temperature is removed from one to another form to change by the virtual effect and what doing any work. But here doing any work and something different from this is by the effect in real life, in real virtue, is by the pressure and volume. So that the flow energy is pressure and volume plus internal energy explained by U. Internal energy shown by the U, and after that entropy. Entropy in a simple way say that the disorderness of the molecules. What is the disorderness of molecule? We say that the heat is a disorder, heat is a disorder form. So what is the disorderness of molecules? The molecules are disordered by the effect of temperature, so that the something energy, something heat is conserved here. So that entropy is work on it. Entropy is work on it. Entropy in a simple way, disorderness of the molecules is the basic definition. This. So after this, explain a law of thermodynamics. This is the basic terms are used here time to time. So explain here law of thermodynamics. Explain law of thermodynamics. What is the law of thermodynamics? Thermodynamics law in my language is number form 0, 1, 2, 3. 0, 1, 2, 3. Why we say that the 0, 1, 2, 3? Because La is number as 0, first La, second La, third La, and so that the La is number form. 0th La and first La, third La, first La, second La, and third La. Explain all the La, then you think all the things about the related to application. When we talk about the 0 La is related to temperature. That's mean the when two bodies are connected to each other, then the third body also connected to each other if all in thermal equilibrium. Thermal equilibrium, that means the temperature constant, then the all body have same temperature. That is called the zeroth law, or say as in my language is the temperature law, because first body is temperature T1, second body is temperature T2, and third body is temperature T3. Connect to each other. They have different temperature, and after some times they have temperature equal. T1 is equal to T2, T2 is equal to T3, and after that T3 is equal to T1. That is the what is the process? T1 is equal to T2, T2 is equal to T3. The temperature is constant after the thermal equilibrium. Then thermal equilibrium. Why we doing this? Because he explained the reference point of temperature to another bodies. So this zeroth law is using a temperature reference. What is the meaning of temperature reference? That's mean that this temperature reference from explain the temperature properties. What is the temperature of behind the any person, any things, any doing thing. So this law is explain the different temperature scales or different temperatures, thermocouples, such as different types of thermocouples, resistance thermocouples, current thermocouples, and different pressure thermocouples, universal First law of thermodynamics. First law of thermodynamics. After this lecture, we explain some problems, some projects related to our thermodynamics, so that we explain all the things. And I want to say that Mr. Alex, please these projects explain in next lecture if you have a time. By me, these are several different projects in our lives, and nowadays the Atmanirbhar Bharat is changed from one form to another form, such as suppose one as a Sri Rams, and another as Allah, another as a Guru Govind, another as a Christian church using as a Isa Masih. So that there are the different types of dharma. That's the spiritual, that's the God law. God is not created, not to be destroyed from the any others, and so that they form to another form by the virtual use. When we use our God in our perspective, so that the gods are doing here by names. By I am Ramji Tripathi, so that God's my Hindu, and my name is Iqbal, that's my God is Allah. So that first law of thermodynamics, it depends on the God law in my language. So don't be serious, don't be worry about this. Sorry for any heard this as don't heard this, because God law as a God is everywhere and God is all of us. Because I am Hindu and you are Muslim, and also Sikh is and also Isai, all have a God, his own God. And why we say at the own God? Because my God is in several form, and in my way this God is in this form, so that we form of that synergy conserved from that areas, from that one we pray the God of Sri Rama. But why we pray the God Sri Rama? Because we think about the Sri Ram characters is different from, in my way is different from, and observe we covered in conserve energy from that sphere, because we know that very well, energy cannot be created nor be destroyed, it's only change from one form to another form. And we are the soul, that means we are the system, and all of the system is surrounding, and in the universe, system plus surrounding is equal to universe. So in my language, God is the first law of thermodynamics, God law. That means energy cannot be created nor be destroyed, it's only change from one form to another form. And one form to another form, that's mean simple, Q is U plus W. Why we see that Q, U plus W? What is the meaning of this? We know that Q is energy, U is energy, and also W is energy. We know very well. But why will this thing Q equal to U plus? Why we not write Q is equal to W? What is the meaning of U? In previous explain here the internal. Sorry for interrupt because of due to internet connection. Sorry for disconnect due to internet connection, interrupt for this. We explain the God law and the first law of thermodynamics. First law of thermodynamics is Q is the energy, U is the energy, and W is also as a energy. When we explain the energy in a simple form of U is a internal energy is mixed with any system, and internal energy as a, we say that internal energy as a soul energy, or say that the something point of energy is also in any atoms, molecules, and all matters or materials, so that the energy is here present. And W is a form of energy as a order form, and Q is a disorder form of energy. Here the explain all the energy transfer from one form to another form. One form to another form, that means one form Q, another form change to work, and that's the change form to Q, that means heat. This is a heat and work. This is a heat and work. Here they explain how to do this work for cyclic process. Cyclic process. In a cyclic process, when change anything, the Q is equal to W. Q is equal to W. There is no soul of energy, because next we explain also that there is a God law. Why we say that the God law? God law, that means when we have no souls. They are the cyclic of life. When we learn about the cyclic of life, something sadness, happiness, sadness, happiness, sadness, happiness. That means in a between of sadness, happiness, nothing is present. That means nothing is a present of energy. So that this is the sadness, happiness, sadness, happiness. The whole life is covered to sadness, happiness, sadness, happiness. That means the whole process is led to when order form of disorder form, order form, disorder form, order, that's mean work, and disorder, that's mean heat. This is the several laws. Continue. That's the life, and that is the life and first law of thermodynamics. Life to my life or your life, and explain all the person lives is related to first law of thermodynamics. So that energy cannot be created nor be destroyed, it's only change from one form to another form. It is the conservation of energy. So that this is the conservation of energy law. And next explain second law of thermodynamics. Explain second law of thermodynamics. Second law of thermodynamics. Before we explain the second law of thermodynamics, we explain what is the heat engine, heat pump, refrigerator, or say as the reservoir, thermal energy reservoir. In our first law, several limitations, they does not depend the what is the direction of heat and work, what is the temperature conserved in during the heat and work. Suppose I have a several temperature according to my life, according to my own, according to my things, so that my temperature is changed from when we talk about you. Here the something I have energy. Suppose एक घंटा अब आपके मार दिया हमने, तो वो मेरी एनर्जी के ऊपर डिपेंड करेगा मेरे पास टेम्परेचर कितना है. अगर मान लीजिए मेरा टेम्परेचर ज़्यादा होगा तभी हम मारेंगे, अगर हमारा टेम्परेचर कम होगा तब भी अगर हम मारेंगे तो आपके लगेगी. दैट्स मीन दैट डिपेंड्स ऑन द टेम्परेचर, बट इन अ फर्स्ट लॉ दैट्स कैन नॉट बी एक्सप्लेन these several things because this is the God law. God law, that's mean the power of law. The first law is the power of law. Second law is according to by my ways, according by the virtual use, because God says several energy. So several energy have several temperature. Several temperature, we want something temperature. Suppose several characteristics of God. Suppose Isa Masih says that the please help to other, please help to other, please help to other. So that help to other is some one properties. So that in our second law of thermodynamics, several temperature Q1, several temperature T1, that's the properties. One T1 temperature and use these several properties from the another things, use them. This is the second law of thermodynamics. We learn the explain all the energy. So here explain heat engine, heat pump and refrigerator. Before we explain heat pump, refrigerator, explain this T1 temperature, that's it, T2 temperature. What is the mean of T1, T2 and what is the figure out this? This is the source of heat, and this is a sink of heat. This is a sink of heat. Why we say that the source of heat and sink of heat? What is the mean of source of heat? Reservoir, that's mean conserve of all energy, that's the conserve of all temperature, where the remove some temperature there that does not affect the something is reservoir. Suppose in our home several tanki where the some water, and if the water is low, then we use the pump and then next level to fill up the pump. So that the source and sink are the two types of reservoir. Source, that's mean the heat gain, and source heat is given to them, and source then heat collect from them, and this is the cyclic process. This is a cyclic process. Cyclic, that's mean one form to another form, there are no change of point. In our lecture we does not explain the point function and path function, and after this if I have a time then explain a path function and point function. This is missing from me. Then temperature, high temperature source and low temperature sink. There are the three figure. Why we explain three figure? This is the heat engine, in my language heat engine, work and remaining heat goes to the sink. So that this law here to explain as heat and work law also. But in a heat pump, here heat pump, he goes from low temperature to high temperature. He goes from low temperature to high temperature. Our denotation is same like as, but explain all the things by 1 to 1, by 1 to 1. In a heat pump, heat transfer from low temperature to, that's mean low temperature to high temperature, low sinks to high temperature source. In a refrigerator also this is a low temperature to high temperature. But what is the difference between heat pump and refrigerator? Here the simple, in a heat engine same our refrigerator system, but in a heat pump we want to high temperature, but in a heat pump we want to high temperature, so that when we explain the low temperature to high temperature, this is required from work, because the heat comes from low to high is not possible without the external effect of work. When heat transfer from low temperature to high temperature, it is not by the work. If work is not work is absent, so that this is not possible. So here we also work is required, but to in condition of heat pump, low temperature surrounding, and in a refrigerator, high temperature surrounding. This is explained by the in a second law, using in a second law. So that how to explain this heat engine, heat pump and refrigerator in a simple way, we say that the high temperature source of heat transfer from engine, high temperature source goes to the engine and doing any work, and remaining is goes to the sink in a heat engine. When we say about the heat pump, low temperature heat goes to the high temperature, low temperature heat to goes to the high temperature source and require the external work. But in a refrigerator, low temperature heat to goes to the high temperature but require a high temperature surrounding. So what is the use in our lecture, second law of thermodynamics? So one property for this and one property for this. What is the mean of this property? I love this here, then explain. First, suppose a property this in a heat engine, if any COP. What is the mean of COP? Coefficient of performance. In your book you explain the coefficient of performance. When we doing any work, when we doing effort, then using performance. When our work has come, then efficiency. If I have efficiency, then that means I am doing any work by the effect something else. But in what is the performance? That means I have low performance, that means I have less data, of less knowledge, so that gain knowledge from anywhere and improve my performance. That means this is the performance depend. So that when we explain the coefficient of performance or any performance is depend on the desired effect upon net work. It depends on the your performance is only desired effects. What is the desired effect? That's when the desired effect in our figure we explain the heat pump require low temperature to high temperature, but low temperature surrounding we want to high temperature, so that the desired effect is Q1 upon W. But this is called for the heat pump, and when we called about the refrigerator, desired effect is low temperature, so that here the high temperature, here the want upon network W. In our refrigerator system, explain here, in our refrigerator system we want also low temperature, because we want to cool the temperature of the substance by the virtual effect of doing any work. What is the doing any work from this? This doing work by the compressor. Explain in next to that. And after that, this cover, the second law comes in our nature. Second law by the Kelvin and Clausius statement. Kelvin say that the low temperature heat, high temperature heat, by the Kelvin. Low temperature heat 2 goes to high temperature heat without effect of work. Gaseous heat, high temperature heat to device. It is impossible to make a device. So that Clausius we say that also Clausius say that it is impossible to make a device high temperature heat to work, but no goes to the sink. So that this explanation of second law of thermodynamics. After that, third law of thermodynamics. After that, third law of thermodynamics. Third law of thermodynamics basically say that at absolute zero temperature there is no entropy. What means entropy? Explain disorderness of the heat with respect to temperature. That is entropy. And at absolute temperature, absolute zero temperature, no entropy. No entropy. That is not possible. So that in our lecture these are the cover all the law of thermodynamics. But in here present, what is the application of thermodynamics? What is the application of thermodynamics in our lecture? Explain the what is the application of thermodynamics? Without the thermodynamics engineer, petrol engines, gas turbine engine, steam turbines, modern industrial society could not survive. But there is the explanation of nature, finite global resource, oil or coal, result in massive atmospheric pollution as the humankind insists at present on the continuance of industrial society. A study of engineering thermodynamics, that means the essential, because it's related to geothermal, chemical, several related to electrical, and also the common as. Before explaining all the law, all the things, first is main important air and steam working substance for the thermodynamics. In our thermodynamics lecture, after single element such as nitrogen, hydrogen, oxygen, such as the nitrogen, N2, hydrogen, oxygen, and compound such as water and H2O, substance with fixed chemical composition can be a single element such as the nitrogen, hydrogen, and mixed such as the air. So that the air and steam is most important. Those who are the HVAC engineer, that means heat, ventilation and air conditioner engineer, they work on the air and steam. That's when air and steam, this is the air and water. In our atmosphere, there are several application of the energy, but we want to all my dear students learn the all of energy is present here. What you want there, the energy. Suppose we want to change the life of the board. What is the requirement? This is the requirement. The thing, this will be converted from one to another form by the using of one energy to another energy. When we using the electrical energy, there's the board is the electrical form of energy. Then the using here the manually transfer from one form to another form. Here the adhesive energy, when we write about the air, steam or the all the things, there the adhesive energy comes from. Responsible for the receiving and removing dynamic energy is the working fluid. That means the working fluid is most important. Air and steam is called the pure substances. Pure substances. Pure substances, they are in the substances with fixed chemical composition. Example, steam and water and mixture of steam and water. Third, heat transfer. These are the basic rules which engineers want. Engines doing any work, HVAC, heating, ventilation, heating, ventilation, air conditioning, heat transfer, that's mean modes of heat transfer. These are the basic rules for the thermodynamics, in which it deals the different types of energy related to them. So that there are different types of process, reversible process, irreversible process, second law of thermodynamics, and the heat engine or Carnot engine, Carnot cycle, absolute temperature scale, Carnot cycle with a perfect gas. Then after that the Otto cycle, air standard cycle, that's mean where the using a air as a working substance, air standard cycle. This is the diesel cycle, Otto cycle, dual cycle. Analysis of combustion and problems such as related to any engineers want to the something that will be combust that the combustion energy from fuel to another form, such as the petrol they are combust after that the change form of energy due to the chemical energy and practical determination of the calorific value. After that the steam cycles. In a steam cycle, the Rankine cycle, reheat cycle, regenerated cycle. Further, the consideration of plant efficiency. In our thermodynamic plant, there are the several types of energy are covered. And after that the gas turbine cycle. In a gas turbine cycle, the practical gas turbine cycle and modified gas turbine cycle, these are the covered are the thermodynamics. And after that we explain the application. Here the application of thermodynamics, this and jet propulsion. Second, steam and air cycles. Third, rotadynamic energy by the using of fluid property, psychrometric properties, and this is the I can't explain here. I can't the point on the several types of this is the application. This is the, because we know that the first law of thermodynamics, God law, that's mean the God law. Here the when we talk about the God law, that's mean that covers all the energy. This energy by me, by the virtue, by the our engineer, by the types of engineer, what do you want as per source of energy, that's the explain on energy. This is a several application, this is several the minute application of energy, nozzle and jet propulsion, steam and air cycle, and all the engineers are they doing anything, several nozzle properties changing, suppose less pressure, oppose jet propulsion and different types of jet propulsion according to this. But we want to learn new things. We want to learn new things. Energy comes from where, how to come from energy, and how to change from one form to energy form by the using of material, by the using of virtual materials to from one to another form. Then after that, positive displacement. Then this is the all the multiple stages energy and reciprocating internal combustion engine, 4-stroke, 2-stroke, other types of engine criteria and the performance of the engine, focus on the factor affecting the energy. Then there are several types of thermodynamics. These are the cover thermodynamics, so that the thermodynamics lecture is not covered in 2 hours. So our main topics is aims of the give to student energy engineering through the grounding in the subject of thermodynamics, and design the thermal plant, designing the thermal plant and plan, organize the project. What is type of project? Suppose I am such as a HVAC engineer. I am also as a mechanical engineer, and I work on different types of refrigeration and air conditioning system project. We want to the how to remove the energy, humid energy. The word as a humid energy is not good. How to remove the humid, and why with remove the humid, and this is the most important for this, because this is the something irritating for us. So that we learn the different types of related to project as a desert cooler is come from the, and how to lose the desert cooler, and how to conserve the moisture to our energy form. This is the basic rule for the thermodynamics in my mind. And according to your mind, what is the cover, it depends on the your performance. It depends on the your doing any work related to thermodynamics. But when all living things depends on the energy for survival. Suppose modern civilization continue to dream only if exist source of energy can be developed to meet the ground growing demands. Suppose energy exists in many form of energy locked in it. The atoms of matter itself to interest radiant energy emitted by the sun. Many source of energy exist, many are the known, some perhaps unknown, and but what energy source exists mean must first to be transfer the energy into the convenient to our purpose. What is the our purpose of energy to transfer from one form to another form? It depends on the your choice. It depends on the your spoon, what you will be pick up from the energy. Suppose here you learn this lecture by me, that means you using the frequencyal energy by using the software and different types of platform as a Facebook. This is depends on you, what do you want, so that the energy is also depends on you. Suppose the chemical energy of the combustion of fossil fuel such as oil, coal, gas, and waste energy, agriculture, industrial, domestic is used to produce heat, which is turned to use to provide mechanical energy in turbines or reciprocating energy. Uranium atoms are bound to nuclear energy, and that they are the several bombard ascender. There are the nuclear energy form by using the potential energy of large masses. This is depends on the energy form. So that in our lecture of thermodynamics explain all the things, basic rules. Because of the basic rules, suppose in my mind we want to the such as a system as a thermodynamics isolated system. In my mind we develop a system, thermodynamics isolated system. So that what we will be doing as a isolated system, in my mind isolated system, that means neither energy transfer not mass transfer. So that a system is types, there is nothing transfer, that means nothing doing any work, because no transfer of energy, no transfer of mass, that means not doing any work, it's have own energy. So that's we make a such type of object that does not convert the energy one form to another form, but by the effect of this doing this project, this is the transformation of energy doing very well work with them. But in our suppose in a cold climate, engineer want to such as a climate of room, so that the not transfer of energy from involves to from the surrounding, so that maintain a temperature of room with respect to that energy, so that he in mind, so that not transfer of energy, not transfer of mass, so that what is the mass of air, that's the conserve, and after that when we open, that's the mass is also transfer from, and when closed, that's the mass is fixed with others, so that this is the doing any work with them. This is the simple example, and we say that the thermal energy converts solar energy, electrical energy, mechanical energy, hydro energy, nuclear energy, chemical energy, and geothermal energy. These are the conversation of energy in different form. Different types of thermodynamic components such as the turbine, compressor, condenser, such as a turbine, compressor, condenser, radiator, evaporator, nozzle, and our IC engine system, piston connecting rod development. These are the several types of projects and related to us. They doing any work, doing any things, energy, transfer of energy from one form to another form. So here explain one to one. I am not given to these ideas is exact to us, using in mind how to use them. Because when we talk about with the Alex, Mr. Alex from the Hnaoi University of Alex, Mr. Alex, the branch is related to not a mechanical. He is managing director of the event. His branch is MBA, and say that if you are able to, I give two opportunities to explain the thermodynamics lecture in your own ways. And what is the most important, and there are the several lectures on YouTube's on different types of scientists also explain the. But why we study about the thermodynamics, then go given to the students some ideas in my mind. This is this suppose so that I say that the Mr. Alex and promoter ma'am ALENE, I ask them. Then there are the several types of thermodynamics laws, and I explain some interviews. Then they say that this is good for our students, but it depends on your. I say that them this is depends on your what do you doing any work. So that here they explain all the some projects related to our thermodynamics. They doing any work. And according to you doing any work and them. And sorry for Mr. Alex, these are the projects growing to India. Also the projects are related to the our Vietnam and other countries, those watching for our lecture. This is the basically we cover in India lots of the several requirement. So that the first isothermal vehicles development. Number one, projects related to thermodynamics. Isothermal vehicles development. Second, energy comes from humid atmosphere. That means humidifier energy system. In my language, this is the humidifier energy system. Third, convert waste energy of voice to doing work. That means there are several systems such as this is mic, transfer from one energy to form another form. You explain loud sound or the greater soundness properties, but we want to convert waste energy of voice. When we explain all the things in different way, the transfer of energy, some of sources, some of relevant to our example as then I say that this name is sound NEMA energy system. Sound NEMA energy system. Why is it there is sound nima? Sound nima, that's a sound is coming from them. This is a sound nima is a system in my language. This is not in your YouTube channel or on Google. These are the projects are different from this. You search isothermal vehicle development. That's next. Then fourth number, convert waste energy from thunder. This is the thundering. Convert waste energy from thundering sourcing development. By the using of low cost project, using the thunder and explore that thunder energy to our real life. Here there are lots of losses by the thunder, but we want to use the thunder and develop the sourcing of development and sourcing the development of energy. So the development thundering sourcing development system. This is new type of projects for the relevant engineers. And last 5, convert rain to source of water convert the rain of water to form of electricity. Here I explain not explain the as a light of rain. Here they explain the rain of water to form of electricity. Rain of water have lots of area where the rain comes and losses them. So that explain these the rain of water convert to electricity by the virtual use. Here the not as a whole source to given to peoples in environment, in atmosphere, but we want to as a convert rain convert to energy from electricity by the virtualized effect. These are the projects related to others. Next, fifth for environmental engineer, those learn the different types of energy sources such as the psychometric, but is the difference from agriculture sources. Environmental plants and trees growing property analysis with them energy. That is the plant transformation with the energy is given to us. So that this is the different types of lectures with them, and the time is over for our lecture. And thermodynamics is the branch that does not cover in 2 hours, is the wide branch that cover all the things. Suppose we say that in previous thermodynamics laws and properties and different types of process function, and after that the cycle, steam cycle, and kind cycle, combustion engine, Otto cycle, diesel cycle, and then several types of ideas, several types of projects. In this lecture only explain what is the important and how to important to own this God's law you never listen to God's law as we use as a thermodynamics law. So that this is the most important lecture for those students those want to something new about the related to the lectures. Suppose they want to the something new ideas. There are 5 ideas are different from Google's or YouTube's or the different times, but these ideas explore its own your choice. If your choice is you something different from this, suppose you want to change the steam engine in your own ways, as your depends on this, but you want to the loss of steam engines, loss of energy from the steam engine and using them, this is the most important for this. But several engineers doing something new, but they don't have the loss of energy where the in atmosphere the everywhere the source of energy, so that our requirement is to and request to our dear students, please learn the source of energy and how to collect the source of energy, and that's the energy sources to require a particular form of projects from of several uses as agricultures in India, and also the uses in plant structure or thermal plant, nuclear plant, steam power plant, and there are the several plant. So that in our lecture is thanks to again from the university's director ALENE from the Hnaoi University, and also the thanks for the organizer Mr. Alex and also the ma'am promoter to promote them this lecture, and for this thermodynamics ma'am ALENE KARAU, and also the thanks of Right and Perfect Academy Mr. ANAND Singh KUSHWAHA sir, and also the family members who supported them in lecture doing any different from the others presentation and other lecturer and other professors different to the things you involve them, so that the your lecture is going, and also very thanks to watching for us, and also thanks to those persons like our lecture, and also thanks to God for giving me opportunities to them this type of lecture for your enhanced knowledge and enhance the project system related to the thermodynamics. And thank you. And again, if you want to join our teams Right and Perfect Academy, so that like, comment, share with the Right and Perfect Academy page in FB, in a Telegram, also in a YouTube channel. And in a YouTube channel there are several types lecture series, mechanical related, class 10, NCERT related, and also for the non-tech student, aptitude students, those students want to learn the aptitude, reasoning, also the current affairs lecture on early morning 4 AM. It's first time in your YouTube search which have current affairs early morning. In our Right and Perfect Academy presented the current affairs first, so that please subscribe our channel, and also if you have not subscribed our channel, watching for us, and enjoy and staying home, and stay with home with parents, and be safe at home, and thanks also, and God bless you because of this time off is not good for every person, so that please stay home in Vietnam University Hnaoi, and thanks for this covering lecture. Thank you.